let's continue to look at matrices here in this video. We're going to specifically look at if two matrices are inverses of each other. We can look at this from a few different ways. One of the ways is just from this statement of this theorem, which says that two matrices, A and B, are inverses of each other if and only if their product is the identity. And to review real quickly, when we deal with 2 by 2 matrices, the multiplicative identity is this 1, 0, 0, 1. Okay? So, we're going to apply this fact in this video. What we're going to do here is answer the following question. There's 2 examples. It says, are the following matrices inverses of each other? Well, I could just simply apply this fact by computing their product and checking to see if I get the identity. If I do get the identity, the answer is yes, they are inverses of each other. And if I do not get the identity, the answer is no, they are not inverses of each other. So let's try to put this fact to work, and what I'll do in these 2 matrices I'm given here called A and B on the left, I will just compute their product. Okay, so I'll just make a quick little note here that I'm going to cross out the end, put a big dot there. Okay, and show you that I'm doing multiplication. First thing I'll do, which should be decently obvious at this point, is the inner-outer rule. Well, we have 2 by 2 matrices. The inner rule states here that yes, we can multiply them, and we will in fact get a 2 by 2 answer. So let me set that up. Okay, so just straightforward multiplication here. I'm going to use the top row and the left column to compute the entry that goes in the top row, left column of my answer matrix. So I'm going to do 4 times a half, because they are both first. And to that I will add 1 times negative 1, because they are both second in their respective row and column. Continuing on to go into the top right part of the matrix, I will use the top row and the right column. And if you see why I have this circled here, the 4 will multiply the negative 1/4, and the 1 will multiply the 1, because they are in matching positions for their respective rows and columns. So we will get 4 times negative 1/4 added to 1 times 1. Continuing on in a similar fashion, to go here in the bottom right corner, the bottom left corner of the matrix, I will need the bottom row and the left column. So 4 times 1/2 plus 2 times negative 1. And I'll continue on again. To do the bottom right, I will use the bottom row and the right column. So that's going to do 4 times negative 1/4 plus 2 times 1. And matrix multiplication is something you should have decently well mastered by the time we get into studying inverses. And then I will just simplify these 4 entries and see that half of 4 is 2 plus negative 1 will give me 1. 4 times negative 1/4 is negative 1, plus 1 here will give me 0. And then bottom left, half of 4 is 2, plus negative 2 is 0. And then the bottom right, we're going to get 4 times negative 1/4 is negative 1, plus 2 is 1. So we do see that this is in fact the identity when I compute the product. So the answer is Yes, A and B are inverses of each other. Similarly, I shall move into this problem where it's asking me if A and B are inverses, so I'll just ignore the A and B notation there and just set up the opportunity to do A times B. And again, it's a 2 by 2 by 2 by 2. So it's obvious because the inner numbers we can do it, and the outer numbers dictate the size of the answer. So I will set up a 2 by 2 matrix. And I'm just going to take a second here to draw the answer matrix. And we see here something curious here. We see that each individual entry is the multiplicative inverse of each other in these matrices. Like the multiplicative inverse of 3 is a third, multiplicative inverse of 6 is 1/6, multiplicative inverse of -2 is -1/2, and multiplicative inverse of 7 is 1/7. So maybe they'll be inverses of each other. It seems like I just took the left matrix and did all the individual inverses, so let's see how it turns out. So here, to go into the top left column, the top left position of the answer matrix, I'll use the top row and the left column, so I will do 3 times a third plus 6 times -1/2. And let me just simplify that down here. And I see that I'm going to get 3 times a third is 1, plus -1/2 of 6 is -3. So -3 plus 1 is -2. Well, if you're astute here, you realize very quickly that this entry has to be a 1 for it to be the identity. So I actually can stop right here. A little disappointing in some ways. I was hoping these would be inverses, but the answer is in fact no, they are not inverses of each other. Just to reiterate, I hope we can make that observation here. We said when we took each of these individual entries and took their respective inverses, we actually did not get the inverse matrix. Similarly, on this one on the left, where they are inverses of each other, notice the individual entries are not inverses of each other. The inverse of 4 is not 1/2 with regard to multiplication. Similarly, the inverse of 1 is not -1/4, etc., for the rest of those entries. So it does not work as intuitively as you think. It is, again, based strictly on this fact, which states 2 matrices are A and B are inverses of each other if and only if their product is the identity. So when asked if 2 matrices are inverses, take their product. Then just match it to the identity. The product is the identity, the answer is yes. The product's not the identity, the answer is no.